Hello and welcome back to the DSA classes. Today we are going to be solving a very commonly asked and equally interesting question for bit manipulation, right? Now the name of the question is lonely integer. On Hackerrank it is called as lonely integer. Different platforms have different names for this question, right? But let us understand the question first. You are given an array of integers, friends, where all elements but one element occur twice. Find the unique element. For example, look at this 1, 2, 3, 4, 3, 2, 1. Every element occurs twice. 1 occurs twice, 2 occurs twice, 3 occurs twice, but 4 does not occur twice, it occurs only once. So that is the unique element, or that is the lonely integer, that is the single integer, and that is what you have to return. So as you can see, they are asking a function called as lonely integer function, so I'll just copy that. And what this lonely integer function has to do is, it has to basically take an array as input, an array of integers, and what it has to return is the element that occurs only once. I think it is quite straightforward question. And if you look at the constraints, it's very important here. It is guaranteed that n is an odd number, which means the size of the array, the number of elements in the array is odd, number one. And there is one unique element. Obviously, if every element has a pair and only one element does not have a pair, don't you think the number of elements will be odd? That's what they are saying. And it is guaranteed that n is odd and one unique element will be there. I hope you are able to think. Now that you understood the question, let's go and try to come up with different logics, right? So let us not directly write the most efficient logic. Let's build up to the efficient logic. So watch it, all of you. I have an array here in front of me. I am going to fill this array with these elements. So it is 5, 1, 4, 4, 5, 3, 1. These are the elements that I am going to fill it with. Now you tell me which is the lonely integer here. Anyone who has eyes knows that it is 3, because every other element occurs in pairs. I hope you are able to think. So a brute force approach, a naive approach, what could it be? What I would do is, right out of the box, to check whether elements are pairs, best way would be if they come next to each other, right? If the pairs came next to each other, it will be easy for me to identify. So what I will do is, I would like to sort this array. The moment I sort it, you can see I've got double 1 followed by one single 3, then double 4, double 5, which means clearly I can now see that my number 3 or integer 3 is the lonely integer here. Now, how are we going to find this? Well, very simple. This is how my algorithm is, okay? I'll start a loop where I begins from the 0th element. I begins from 0. Now, what I will do is, inside the loop, so I'm just writing for I starting from 0 to, for the time being, let us write n. Let us write n. It will go to the end. We'll see if we have to fix it. Inside that, what I'm going to do is, I am going to just check if in case the element present at array of I and array of I plus 1 are the equal, which means I am checking whether these two elements are equal. If they are equal, it is not a lonely integer. If they are not equal, only it is a lonely integer, right? So if it is not equal, that ith value is my lonely integer. So that is my condition. If in case array of I is not equal to the next element, array of I plus 1, then I will come inside and I will return I. How are you able to think? And will that work? Certainly. See, array of I plus 1. Are they same? Which means if condition will not work, which means I am within a loop. Now look at this. I is here. Should I move forward by 1 or should I move forward by 2 positions? Anyone who has eyes will say, sir, it has to move by 2 positions because we are checking pairs, we are checking adjacent elements. So see, I is moving by 2 positions. Is array of I and array of I plus 1 the same? No. It is not the same. Why? Because as you can see, 3 is a lonely integer, next one is 4, so they are not the same. If they are not the same, the element at the ith position is your lonely integer and all you have to do is return I, and that is what I am telling, return I. Correctly you found? Great. But your logic will be incomplete if you don't think of another situation. Let us assume I'll remove the elements in the array and replace it with these values. So it's 5, 1, 4, 4, 3, 1, 3. I hope you're able to think. Now, if you look at it, which is the lonely integer? If you ask me, it is 5, right? And according to our algorithm, first sort the array. If I sort the array, I will get double 1, double 3, double 4, and the last element is 5. I hope you will think that is my lonely integer. Now see, I'm applying my algorithm. I starts from 0. Okay, check. Yes, both of them are equal. So not equal condition will not work. Move I by 2 positions. Check. Are they equal? Yes. Move I by 2 positions. Check. Are they equal? Great. Now look at this. If I move I by 2 positions, I'll come here. This is I plus 1, nothing is there. Nothing is there. If nothing is there, say I'm putting an X there, don't you think if I go outside the boundary of an array out of bounds exception can occur? It can occur in Java also, it can occur in Python also. Definitely any linear data structure, any index based data structure, if you try to access an index outside it, problems may occur. I hope you're able to think. So what to do if you ask me? Would you agree? I should not go till here, I should come back 2 positions. I should come back 2 positions. So what I will do is that boundary condition I will tell, hey, let I start from 0, but let I go till not n, but less than n minus 1. See, n minus 1 means, or n minus 2 we can say here in this case because it's 0 based indexing. N minus 2, less than that means I will be here. So I will go only till here. I hope you are able to think. Great, but see here, you, according to your logic, you compared these 2 elements, you compared these 2 elements, you compared these 2 elements, but since I stopped here, you are now not comparing this element. You are not comparing this element. If you don't compare this element, this is your lonely integer. If I came till 4 and it did not find a lonely integer, then obviously the last element is your lonely integer. I hope you're able to think, which means if I come out of my loop, and I've not found a single lonely integer, Hackerrank has guaranteed me that there will be a lonely integer. So the obvious conclusion is that only the last element is the lonely integer. So what will I do? I will return array of n minus 1. That is only nothing but the last integer. I hope you're able to think. Any confusion till this point of time? Now, clearly, this is a brute force approach. This is a naive approach, right? In terms of time complexity, it is going to be very, very bad because look at it. First and foremost, you have to do sorting. How to do sorting, we will see. You can use any of the sorting algorithms. But let us assume the best sorting algorithm will have a time complexity of log n. So see, for sorting, time complexity will be around n log n, right? And here, in a way, you're going till n. Right? Which means it is going to be n plus n log n, something like that. Which means it is definitely not efficient, right? It is not efficient. So how to make it more efficient, we will see. But first, let's go write code for this. Watch it, guys. In Java, it's very simple. I'll just have to write this function. So I have my array. I'll just have to loop over it directly. So I'll tell for I'll tell int I equal to 0 and I less than array of length minus 2 and then of course I'll tell I equal to I plus 2. Every time by 2 times it has to do. I'll come inside this, scroll it on top. Yeah. Now what I will do is I will directly start comparing. So if in case array of I not equal to array of I plus 1, that is adjacent elements. So if the adjacent elements are not pairs, then it's a lonely integer. So I'll just return array of I. However, you know, according to our logic, if in case here it does not find the lonely integer, then the last element is the lonely integer. So see, I'll come outside and one more return statement I will apply. Indent it correctly. Yeah. So there I will just still return array of last element is nothing but length minus 1. Good. So this logic will only work if our array is sorted first. So sorting has to be done. So very simple. I'll go on top and we can just tell arrays dot sort and a like this. Now listen guys, this will probably take around n log n, big O of n log n. This will take around big O of n, right? If you add both of them together, it will be big O of n plus n log n. Now the lower order terms are ignored, which means n goes, and what remains is n log n. So the time complexity is around n log n. I hope you're able to think. It's again not at all efficient. Now if in case we go and if we submit the code or run the code, so you can notice that clearly all sample test cases are passed. If I submit it, then all the test cases will pass. Definitely test cases have passed, but that doesn't mean that you're writing an efficient solution, because this course is all about making you an efficient programmer, right? How can we make this more efficient and bring down the time complexity from n log n to a little lesser? Let's explore. Now there is definitely a more efficient approach. Now what is the efficient approach, may I ask? But this efficient approach has a catch. The catch is that I need some extra memory to do this. Why, you may ask? See, what I will do is, this is available in Java as well as in Python, I will make use of a set, guys. I will make use of a set, right? Now, what is unique about a set, if you ask me? A set is a data structure which can only and only store unique elements, right? And somewhere we are also trying to identify unique elements only. So how does this work, you may be wondering? It's very simple. I'm going to create a set like this. I'm going to create a set. Now, I'll call this set as yes. Now, what I will do is, I will iterate over my array, right? That is I. What I will do is, I'll take I and I will first check if in case that an array of I is already there in my set. If it is already there in my set, then I will remove it. What does that mean? You will see. But if it is not there in my set, I will add it. Right now, obviously, 5 is not there in the set, so I will add it. Great. Next, I will move forward. Next element is 1. Is 1 there in the set? Not there. I will add it. Next, I will move forward. 4. Is 4 there in the set? Not there, so I will add it. Next, I will move forward. Again 4. This time tell me, 4, is it there in the set? Yes. If it is there in the set, forget about adding the 4. The existing element in the set, the existing 4 in the set, I will remove it. See, I am removing it from the set. Are you able to think? Now, again I will move I forward. The next element is 5. Is 5 already there in the set? Yes. If it is there, I will not add a new 5. Existing 5, I will remove it. See, the set changed. Again I will move forward. What I have is 3, right? Is 3 there in the set? Not there. So I will add it. Next, I will again go forward. Next element is 1. Is 1 there in the set? Yes. Since it is there, I will remove it. And hence, obviously no more elements are there. Iteration stop. Look at the set. Which is the only element the set has, friends? 3. And is 3 your lonely integer? Yes. How are you able to think? So clearly here, sorting was not required. Sorting was not required. You have to just iterate till the end. So if there are n elements, then n iterations you have to do, which means would you say it is big O of n? Simple logic. But time complexity reduced from n log n to n. Wonderful. But do you see extra space was required in the memory? Space complexity has increased. So the trade-off with this approach is time reduced, space increased, right? We would like to avoid having extra space whenever we work with any algorithm. If we can work with the existing space itself, it will be great, but here extra space is required. Anyways, time reduced, but all of you would agree, this is awesome. Ultimately, what did we do here? We added elements to the set only if it was not there. If the element was already there in the set, it means it is a duplicate. It means it's a pair, right? We want the set to have only the unique element. So if we encountered a pair, we remove the element from the set, and this way we ensure that only the unique element remains. Now, how do we write code for this? Let me show you. Watch it, my friends. What I'm going to do here is very simple. I'll first create a hash set in Java. That is the set that you have. So I'll create a hash set, right? So why am I creating a hash set? Because it only stores unique elements. Now, okay, I'll call it as yes. equal to, and of course I'll also put a generic here telling that it can only store integers, because in collections you can store any kind of object. New hash set, I will tell. Caps. Great. Now what I'm going to do there is I will now just go, and next what I will do is I want to now iterate over all the elements in this array. Now I want you to make a habit of making use of these enhanced for loop or for each loop, right? There are two words, enhanced for loop or for each loop. Ultimately, this is something where you don't have to take care of initialization, incrementation, condition, etc. It will automatically iterate over the entire collection. So I'll just tell for, and I'll just tell int I, and colon I will put and tell which array, so that is AR. So this is a for each. Obviously I've explained this in detail previously. So here all I have to do is simple. I'll check if in case this element array of I, right? I mean just I you have to tell, because it's a for each loop, I will have the element, not the index. So I'll check if I is present inside my set. So how will you do that? Like this. I'll check if in case yes dot contains method is there. Contains what? I. If it contains I, then I will remove it. So I will just tell yes dot remove, and what to remove? I. Else means it was not there. If it is not there, I will add it by telling yes dot add. What to add? I. Cool. Any confusion, guys? Great. Now ultimately this is it. Now at the end of this for loop, when I come out, my hash set yes will only have a single integer. I hope you're able to think. So what I will do is now, because it's a hash set, it doesn't have indexes, you cannot be like directly accessing the element. So I'll just you have to use some kind of iterator or for loop. So I'll just use another for each loop. I'll tell for I int I and I will tell yes like this. So there will be only a single element, and that is what you will get in I. I'll just return I. I hope everybody understood. Just directly submit the code. Okay. So one error, so you're missing a return statement. Okay, go on top. So see guys, the thing is, it wants me to put a return statement, because it is like, okay, what if this set is empty, then you will not even have a single element. So it's saying you have to return something, but we know set will never be empty, because the input guaranteed by Hackerrank says that it is going to be an odd array which will definitely have a unique element. So we know it will work, but Java is scared. Java's compiler is telling, if this set was empty, then this code will not work, you will not return anything. You are telling this will return an int, but what if it doesn't return anything? So I'll just tell return -1. I know this return statement will never execute, but it is the expectation of the language. Now if I just go submit the code, clearly everything works. Okay, so definitely what is the time complexity? Big O of n. But what is the trade-off? Extra space. Space complexity has now increased. So is there an even better solution where both time and space complexity both can be reduced? Definitely there is. Let me show you how. Watch it guys. To keep the time complexity as n, right, and also not increase the space complexity, you have to make use of a bitwise operator. Now which is that bitwise operator? It is nothing but the XOR operator. Now how will the XOR operator help you? Let me show you. See guys, I want you to understand something. I'm going to make 3 observations which will help you understand how beautifully XOR will help you in this situation, right? Now watch it. Observation 1. I am doing 5 XOR 5. Now I am doing XOR operation between 2 similar numbers or same numbers. When I do XOR between same numbers, obviously it's a bitwise operator. So 5 in binary is 101, 5 in binary is 101. If you do XOR, you can see all bits are same. When all bits are same, you will get 0, which means all zeros. All zeros, if you convert it into decimal, what is it? 0. So can I say 5 XOR 5 is 0? Which means XOR between 2 same numbers is 0. So XOR between same numbers is 0. Observation number 1. Look at the observation number 2. Now I am taking 5 and I am XORing it with 0. I am XORing it with 0. So number XORed with 0 is what? 101 is 5, 000 is your 0, and as you can see, if I apply XOR operation, then 1 and 0 will be 1, 0 and 0 will be 0, 1 and 0 will be 1. I hope you will think, which means you got 101, 101 is 5. So a number XORed with 0 is the number itself. I hope you're able to think. Beautiful. Now that you understood these two observations, let me show you something interesting. Observation number 3. 5 XOR 5 XOR 4. You can see 5 has a pair, 4 does not have a pair. Now tell me, 5 XOR 5, number XORed with itself is what? 0. So it becomes 0 XOR 4. 0 XORed with any number or any number XORed with 0 is nothing but the number itself. So you got 4. So do you notice, if I do XOR operation between a list of numbers, and if every number has a pair and a single number does not have a pair, ultimately that single number will be the result of the XOR operation. Interesting? Also, please understand, now when you look at it, you may think, okay, this will only work if the same numbers are adjacent to each other or next to each other. No, because XOR operation is commutative. 5 XOR 5 XOR 4 is same as 5 XOR 4 XOR 5. Any combination, anywhere you place it, it is the same because it is commutative in nature. Those of you who have learned maths, you know what you mean by commutative is nothing but A plus B plus C is nothing but C plus B plus A is nothing but B plus A plus C. Everything is same. How are you able to think? Same is the case with XOR. I hope you're able to think. So now look at it. 5 XOR 4, if in case you do. I'm just showing you the binary. It will be just 101 is 5, 100 is 4. If I do XOR, I'll get 001, which is nothing but 1. 1 XOR 5 if you do, if you check in binary, you will get 4. It will work, which means 5 XOR 5 XOR 4 is same as 5 XOR 4 XOR 5. It's commutative. But what you must observe is, if there are pairs in the XOR, they will cancel out. And what will remain is the number which does not have a pair. Now, would you agree this is a beautiful thing which we can use in our program to find the lonely integer? How does it work? Let me show. Now, all these are the elements of the array. Now, see what I will do is, I will first take 0. I will take 0. Then 0 XOR with the first element 5. Then that XORed with the next element 1. Then that XORed with the next element 4, with the next element 4, with the next element 5, with the next element 3, with the next element 1. Now, you know that the numbers are not next to each other, but based on my observations, you know, 5 has a pair, so it will cancel out. 4 has a pair, it will cancel out. 1 has a pair, it will cancel out, which means only thing that is remaining is 0 XOR 3. 0 XORed with anything is the number itself, which means 3, and 3 is the lonely integer. Simple, simple. So would you agree, this as code I can write it like this, where I'll create a variable called as result, initial value will be 0. I'll write a loop where I begins from 0th index, goes all the way till the last index, so 0 to n. I hope you're able to think. Next, inside that, what I'm going to do is very, very simple. I am going to do result XORed with the element, so array of I. Update that as the new result. Iterate. Again, the next element you take, XOR it with the result. If I keep doing that, ultimately result will have that lonely integer which is 3. It works. Perfectly it works. I hope you're able to think. So what is the advantage here? Because the loop is going from the first index to the last index, time complexity is big O of n. Because I did not use any new variable or any new data structure to store the data, my space complexity remains the same. I hope you're able to think. I'm not using any extra space, which means, don't you think I've brought it down to big O of n? So previously it was big O of n log n. Then we brought it to big O of n, but space complexity increased. Now I've brought it down to big O of n with the space complexity remaining the same. So would you agree this is a very efficient way to find the single non-repeating integer in an array, or nothing but your lonely integer? Will this work as code? Let me show you. Alright guys, now very simple in Java, it's a straightforward logic. I will iterate, so I'll use a for each loop itself, and I will tell int I from A. Inside that I will just go, and on top of that I'll create a variable called as result, integer result. Initially the value of result is going to be 0, right? Now why are we doing 0 is because, look at this, this is my array, right? The first element is 5. Now I want result to have 5. So how will I ensure that the XOR operation will give me the same number? 0 XORed with anything is the same number. That is why initial value is 0. I hope you're able to think. Next, what I will do is I will just go here and I will tell result equal to result XOR array of I, or I, because we are using the enhanced for loop or for each loop. Right? Ultimately, result will have your lonely integer, return it. Great. So if in case I were to submit the code, clearly one can notice that all test cases will not pass because it is telling that it is AR. Right, great. If I submit now, definitely all test cases will pass. Great, simple solution, effective solution, a very commonly asked question and a beautiful question to show you the power of the XOR operation. Anyways, I will catch you in the next class with even more exciting programs, but I really hope you guys are typing and practicing. See you in the next class.